Welcome back to the channel. Today, we're diving into one of the hottest topics in modern data architecture, integrating vector databases with data lakes and ETL pipelines. If you're working with AI applications, RAG systems, or semantic search, this video is going to be a game changer for you. By the end of this video, you'll understand how to build production-ready pipelines that can handle millions of documents, transform them into embeddings, and store them efficiently for lightning-fast similarity searches. So let's get started. Let's quickly recap the key players in our architecture. A vector database is a specialized database designed to store and query high-dimensional vectors. Think of them as mathematical representations of your data, whether that's text, images, or audio. On the other side, we have data lakes. These are centralized repositories that store vast amounts of raw data in its native format. Think of Amazon S3, Azure Data Lake, or Google Cloud Storage holding your PDFs, images, CSVs, and JSON files. The magic happens when we combine these two. Vector databases excel at similarity search and AI workloads, while data lakes provide cost-effective storage for all your raw data. But why do we need to integrate them? Here's the challenge. Your raw data lives in data lakes, but your AI applications need vectors. Without proper integration, you're stuck with manual, error-prone processes. Imagine having terabytes of documents in S3, but every time you want to add them to your RAG system, you're running manual scripts, dealing with inconsistent formats, and struggling with version control. Proper integration solves this by creating automated pipelines that can process data at scale, maintain consistency, and keep your vector database in sync with your source data. Let's break down the ETL workflow for vector integration. Extract means pulling data from your data lake, whether that's S3, HDFS, or any other storage system. Transform is where the magic happens. This is where we clean the data, chunk it appropriately, and most importantly, generate embeddings using models like OpenAI's Text Embedding ADA002 or open source alternatives. Finally, load means inserting these vectors along with metadata into your vector database, like Pinecone, Weaviate, or Milvus. Let's see this in action with Python. Here's a simplified example of how this pipeline works. First, we extract documents from our data lake. Then we chunk them into manageable pieces. This is crucial for good retrieval performance. Next, we generate embeddings for each chunk. And finally, we upsert everything into our vector database. Notice how we're handling batching and error handling. These are essential for production workloads. Now let's look at a real-world example using Vector ETL, a popular framework for this exact use case. We're going to build a pipeline that processes documents from S3 and loads them into Milvus. First, we specify which columns to embed. In this case, we're embedding the document title and content, but keeping the original URL and timestamp as metadata. Here's how we configure our ETL pipeline. We specify our source as an S3 bucket, specify our embedding model, and configure our Milvus destination. Pay attention to the chunk size and batch size parameters. These can make or break your pipeline performance. Too small and you'll waste time on overhead. Too large and you might run into memory issues. Let's talk about some best practices that'll save you headaches in production. First, always implement incremental processing. You don't want to reprocess your entire dataset every time you run the pipeline. Second, monitoring is crucial. Track embedding costs, processing times, and error rates. These metrics will help you optimize and troubleshoot issues. Third, implement proper data versioning. When your embedding model changes, you need to track which vectors were generated with which model version. Now let's explore some advanced integration patterns that'll take your system to the next level. Reverse ETL is about moving processed data back from your vector database to other systems. Maybe you want to sync similarity scores back to your data warehouse, or export cluster results to your CRM. For RAG systems, your ETL pipeline becomes the foundation. Every document that flows through gets embedded and becomes queryable for your AI applications. The key is ensuring your pipeline can handle real-time updates as new documents arrive. Multimodal pipelines are where things get really exciting. You can process text, images, and audio in the same pipeline, creating unified vector representations that enable cross-modal search. Let's be honest about the challenges you'll face. First is embedding drift. When you update your embedding model, your existing vectors become inconsistent. Second is cost management. Embedding large datasets can get expensive quickly, especially with paid APIs. Third is scale. As your data grows, you need strategies for parallel processing and efficient resource utilization. The solutions? Implement model versioning, use open-source embedding models where possible, and design for horizontal scaling from day one. The ecosystem for Vector ETL is rapidly evolving. For orchestration, you've got Apache Airflow, Prefect, and Daxter. For vector databases, there's Pinecone, Weaviate, Milvus, and Qdrent. For embedding models, you can choose between OpenAI's APIs, Cohere, or open-source options like sentence transformers. The key is picking tools that integrate well together. And that's a wrap. We've covered everything from basic ETL concepts to advanced multimodal pipelines. The key takeaway? Start simple with a basic pipeline, then gradually add complexity as your needs grow. If this video helped you understand vector database integration, smash that like button and subscribe for more AI and data engineering content. What integration challenge are you facing? Let me know in the comments below. Thanks for watching, and I'll see you in the next one.